Hello AP Calc students at CCTI, Mr. Bashar here once again on a very dreary, rainy Thursday. We expect anything different? I don't think so. Today we're going to switch gears. We're going to get away from the definite integral a little bit, and we're going to talk about separable differential equations. We touched on differential equations very, very briefly a while ago, but now we're going to get more in depth with this topic. In general, differential equations are difficult to solve, so don't fool yourself. Typically at the college level, you take a whole semester or 2-semester course on differential equations. The equations that we're going to see for the AP exam are what we call first-order differential equations typically, and a specific class of first-order differential equations called separable differential equations. So we'll get to that in a moment, what that means. But by definition, a differential equation is an equation that contains an unknown function and one or more of its derivatives. And these are some examples of differential equations. Y prime equals xy, y double prime plus 2y prime plus y equals 0. Or what we have here, this would indicate the third derivative, dy dx, of x squared over y squared, which actually would be a very boring one. You can see why. But the order, we call this first order. We call this second order. This would be third order. Order is based on the highest derivative in the problem. So whatever the highest derivative, that's the order we give to it. But again, we're going to be talking about a specific class of differential equations, which we call separable, and they look like this. They look like the form dy dx is g of x times f of y. We call them separable because we can actually pull these two functions apart, and the goal mainly being to get one function on one side, one on the other, and write the solution in terms of one function. So like the function y written in terms of x. That's what we typically want to do in a given problem. And these are the type that you'll see on the homework sheet that I emailed to you. Sometimes it is impossible to separate these things, and we'll see when we get so far in a problem why we can't separate it anymore. So let's get down to it. Let's look at some examples on how we'd solve it. And remember, what I'm going to show you today is only one way of solving these types of equations. There are actually many other ways, and it's typically not an easy thing to do. We just get lucky with these types of situations we're going to see here, but in general, it's not always as you're going to see here. So let's start off with a differential equation that looks like this. We're going to solve. We have dy dx equals 2x over y. So this is a first order differential equation, dy dx, and we're going to make this separable. So we want essentially y on one side, x on the other, and keeping in mind if you have x, that has to go with a dx. If you have a y, it has to go with a dy. So what I'm going to do is essentially in a way like cross multiply, if you want to think of it that way. I'm going to get the dx over to the right, and I'm going to get the y over to the left. So on the left, I'm going to have y dy equals, and on the right, 2x dx. Okay, differential dx. Whenever you see that differential, you should think integration. So what we're going to do next is integrate both sides. So this is going to be y squared over 2. Now typically we would put the plus c, but we're not going to do that because you're going to see why in a second. So I'm going to put y squared over 2 equals, and this is going to be x squared, and I am going to write the plus c this time. If you would put plus c on both sides, what would have to happen is you'd have to literally say, incorporate both c's in there. You'd have to have another c and say, this c equals this one minus that one. So we kind of want to avoid that, and I'll show you another thing that we do coming up with the letter k. Sometimes we can write in place of c a k, and that happens too. So now what we're going to do is we're going to go ahead and multiply both sides by 2 to get rid of this. Our goal again is we want to get this thing to be y equals. So if we multiply both sides by 2, we get y squared equals 2x squared plus 2c. Now here's what's a little bit interesting. That's 2 times the constant c. So I'm going to make a note here, and I'm going to say let k be 2c. We're just going to let this k, because we don't want to fool around with a 2c and think anything otherwise. So we can let this k be in place of the 2c. On your answer sheet that you will see eventually, because it was written from a different department, they'll just use a big C in place of it, which is okay. So what we're going to get here is y squared equals 2x squared plus k. K stands for the 2c. And now we have a y squared, so how do we get rid of the 2? We'll square both sides. So you're going to get y equals plus or minus the square root of 2x squared plus k. And that is the solution to this differential equation. In other words, this is the particular function that we are searching for. That's a solution to this first order separable differential equation. Okay? So again, let's kind of walk through the steps. We got y on one side, x on the other with the respective differential. We integrated. We wrote the c in terms of a k because we ended up getting a 2c. So 2c stands for k. And then we want to solve for y, so we just do ordinary algebra stuff, in this case taking a root. That's going to be a common theme. You're going to do that a lot. You're going to take roots, you're going to work with LMs, everything that we previously learned, you're going to use that skill. Okay? So that's how you handle one that looks like that. Let's look at one that's kind of similar to this situation. Pouring outside. So here's another one we're going to solve. We have dy dx is 6x squared over 2y plus cosine y. Okay, so we got that. We're going to follow a similar tactic. We're going to get this over here and this over here. So we're going to have 2y plus cos y dy equals 6x squared dx. Okay? So again, we're just swapping sides like usual. Now we're going to integrate both sides. So this is going to be essentially y squared plus sine y equals, that's going to be 6x cubed over 3. So let's see, what can we call that? Can we call that 2x cubed plus c? I think we can do that. And what you're going to notice here is, no matter how hard we're going to try, we can't write this thing as y equals something of x because you have these two y things in the way. We can't factor out a y or do anything like that. So this would be the solution to the differential equation. We cannot separate it, so this is as good as it's going to be for now. So this is a case where it's impossible, it is impossible to go back and rewrite it in terms of y equals all the x's. But it wasn't too bad. Keep in mind, all the normal integration rules apply, so you may have to do u substitution. You may have to encounter an e to the x or an ln thing, trig stuff, all that. Okay, so that's that. Now let's move on to a little more of a complicated example. So how about this one? We're going to solve y prime equals x squared y. Y prime is x squared y. So notice this time we use this y prime notation instead of the differential. So what we want to do first is rewrite this as the differential. So we're going to write this as dy dx is x squared y, just to start off. So we're going to try to do business as usual here. what I'm going to do first is I'm going to get this dx over here. So I'm going to have dy is x squared y dx. And then what I'm going to do is the dy differential is over here, so we got to move the y variable over. So we'll divide it. So we're going to have dy over y equals x squared dx. Notice we can rewrite this as 1 over y dy equals to x squared dx. So now we're in good shape because we'll go ahead and integrate. So we'll take the integral of both sides. This is a special integral, 1 over y dy. That is your ln of the absolute value of y equals, and this is your x cubed over 3 plus c. Okay? Alright, so that's not too bad. We got to solve for y. So we have an ln that has the y trapped. So we got to think back to right before we left school, unfortunately. And one of the first things we did when we picked up online, oh no, wait, that's the pre-calc, not you guys. Well then for you it's a little bit longer actually. We have to use our ln properties. So if we want to solve this for y, we have to raise both sides by e. So you're going to have e to the ln of the absolute value of y equals the ln of x cubed over 3 plus c. So we'll have that. If you have e to the ln of the absolute value of y, that just drops this guy down. So you got the absolute value of y equals the ln of x cubed over 3 plus c. And if we remove the bars, do you know what's going to happen? If you remove the bars, you have to put a plus minus over here, because now you're setting this up to say, well, now we can allow a positive or negative value. So there would be your particular solution that you're in search of. Y equals plus or minus the ln of x cubed plus 3 plus the constant c. This is probably a good place to pause to go back and redo these problems before we move forward. I have 2 more examples for you, and the last one will be a little more of a tricky one that introduces what we call an initial condition, but this is a good place to stop. So give yourself a break, go back, pause the video, and then we'll go forward and we'll look at 2 more problems. Okay, welcome back. Okay, so let's look at on this guy here. We're going to solve xy squared times y prime equals x plus 1. Okay, so here we go. Xy squared times y prime equals x plus 1. First step, rewrite this as the differential. So you got xy squared dy dx equals x plus 1. Next, think about some things that can happen here. What would you rather do? Try to get y over here or keep it here? I think you want to keep the y squared where it is. But if you divide by this x, you set this up to be something nice. So that's going to be something we're going to look at down the road. I'm going to get this dx over here first. So I'm going to call this xy squared dy equals x plus 1 dx. And then I'm going to go ahead and divide both sides by x. So I have y squared dy equals x plus 1 over x dx. And you should be happy with that. Isn't this nice? The y squared with the dy. We got the x stuff over with the dx. So we're happy. We got them officially separated. Now what also is a nice bonus is this guy here, the x plus 1 over x. You can simplify that. So we got y squared dy. This is going to be 1 plus 1 over x dx. To see that, we're able to divide both items by x. X over x is 1. 1 over x is 1 over x. No illegal chopping happened. It was all legal, consensual chopping. So you know what happens next. We'll go ahead and take the integral of both sides. What you should notice so far, guys, is that the integration itself has been pretty light, has been easy. We haven't had anything really whacked out, which is good. Integral of y squared dy, this is going to be y cubed over 3 equals the integral of 1 plus 1 over x dx. This will be x plus the ln of x in absolute value plus c. Okay, so that's not too bad. Now what we got to do is get this 3 out of here, so we're going to multiply both sides by 3. So you're going to have y cubed equals 3x plus 3 ln of absolute value of x plus 3c. And what I'm going to say here about the 3c is, I'm going to say let k be 3c. So y to the third equals 3x plus 3 ln absolute value of x plus k. And now we've got to spring this 3 out of here. So we're going to take the cube root of both sides. So we've got y equals the cubed root of 3x plus 3 ln absolute value of x plus some constant k. And there you go. That wasn't too bad, right? Once again, we saw this idea that we let k stand for the 3c, and we slapped that right in there. So this is a nice problem because it kind of flexes a little bit of your algebra muscle, and you have to, recall some things from the past. Okay, so I'm hoping you're doing well so far. I have one more example for you, and this is a problem where we're looking for a very, very unique answer because we're given what we call an initial condition, okay? A function evaluated at a certain value that merits us to go in and have to find a very particular solution. So we have solve dy dx equals x squared over y squared, and we're given that the initial condition is given as y of 0 is 2. Y of 0 is 2. So we're going to have to come back and see how this comes into play. It comes into play fairly early in the problem. So to start out like we normally do, we want to try to separate them. So we're going to say y squared dy equals x squared dx. So we're off to a good start. Now we're going to go ahead and integrate both sides. So we've got y cubed over 3 equals x cubed over 3 plus c. Now here's where the difference comes in, right here. We want to figure out what this c is. Okay, we want to figure it out. So we use the initial condition that we're given. Okay, so let me stand back and have you look at it. Your initial condition is y of 0 is 2. Y of 0 is 2. Do you know what that means? That means wherever you see a y, you're going to plug in a 2, and where you see an x, you're going to plug in a 0, because y is a function of x. So let's go ahead and figure it out. So you're going to have 2 cubed over 3 equals 0 cubed over 3 plus c. So that means you have 8/3 is C. So that's a very particular antiderivative. And now what we're going to do is just go back to this stage right here now. So I'm going to rewrite this as y cubed over 3 equals x cubed over 3 plus 8/3, written like that. And now we're going to go ahead and solve it for y. So I'm going to multiply everything by 3, and it works out nice. You get y cubed is x cubed plus 8, just like that. And then all we got to do is take the cube root of both sides. So we got y equals the cube root of x cubed plus 8. And this is a very, very particular solution that we were looking for. Okay, so the difference comes in that you have to find what C is. And once we find what C is, we go back to that step before and then solve for y like we did in the other examples. Okay, so I hope this video helps you as you go forward. I could almost guarantee you'll see something like this on the AP exam, and it could possibly be in the open-ended as a word problem, okay? So I hope everybody's having a good day. I know it kind of sucks outside weather-wise once again, but I hear it's supposed to be good weather on the weekend, 70s and sunny. I'll take that. I'll be out there suntanning, believe me. So until next time, Mr. Bouchard here. Enjoy the rest of your day. If you have any questions, please feel free to call, email, text, whatever. Okay? Enjoy the rest of your day.